Hello everyone, welcome back. Today we are going to talk about logistic regression. We have a boy over here. He is a high school boy and wanted to check how many hours he should study to clear the exams. He do not want to give extra hours per day. He also do not want to fail in the exam. So he took some of his previous year's seniors' data and asked them that how many hours they studied while clearing the exam. He created this nice beautiful table over here where he written the number of average hours every senior gave and whether they cleared the exam or not. If they haven't cleared the exam, he has written 0. If they have cleared the exam, he has written 1. Now let's understand how we can utilize logistic regression to solve this problem. We have a nice beautiful equation over here for logistic regression. Gz is equal to 1 upon 1 plus e to the power minus mx plus c, where Gz is the probability of clearing the exam. X is the number of hours given. We have to figure out the best value of m and c so that we can figure out the probability associated to each number of hours. If you see this logistic regression equation very carefully, you will find that there are some components which are coming from linear regression, that is mx plus c. And we have a negative sign on top of that. Let's take some random values of m and c. I have taken 1 and 1 over here and try to calculate the value of minus of mx plus c. I have applied the formula. You can see that for each and individual point or number of hours, we are getting the value of minus of mx plus c. That is minus 2, minus 3, minus 4, minus 5. Here you can see the plot of minus of mx plus c with respect to x and y with respect to x, which is coming as in blue points. If you see the diagram very carefully, you'll figure out that the red line is actually a straight line. And it is quite intuitive also because mx plus c is the equation of line. For transforming these red dots to this blue dot distribution, we have to apply this 1 upon 1 plus e to the power minus of mx plus c on top of these points, where we have already calculated the minus of mx plus c, so we just have to figure out 1 upon the calculated value. And here we are with the gz. Now we have applied the exponential and figured out the value of gz. So this is how the plot looks like. But still the plot doesn't seem pretty well. So we need to figure out the best or the optimal value of m and c so that these red dots will overlap on top of the blue dots or reach pretty near to that. Let's change some value of m and try to see how our graph is moving. I'm going to change the value of m to 2. Oh, it's still going upward. It means we need to go on the negative side. So we are going to put minus 2 over here. And you can see now it is completely opposite graph. It means the m value should remain on the positive side. Then only we will get the same curve. So I'm going to write 1 only and try to play with the value of c. So let's increase the value of c to 5. Oh, it means we have to go to the negative side because while putting up 5, the graph is moving to the upward side. So let's go to minus 5. As you can see, while we gave the negative value of c, we are able to give some better curve over here. So I'm going to write m is equal to 2 and then decrease the value by minus 15. So you can see it has moved little upward, so we have to go minus 10, I think. If you see the curve pretty carefully, you will figure out that when we give 6 number of hours, it is going to give us zero point 0.5 probability. Go to the table and you will see on this line where we have given 6 number of hours, we are getting 0.5 probability. And in actual case, we were failing over there. So our logistic curve is still little bit towards the negative side. We have to little bit decrease the value of C. Now if you see the 6 number of hours, you are actually getting the probability 0.26. So you will not be able to clear the exam. But once you go to the 7th, you are getting a probability 0.73, which is actually higher than 0.5. So you will be able to clear the exam with 7 hours study. We do not want to go with this random method every single time. So we have to figure out some sort of cost function, then give it to a gradient descent or some optimization method to figure out the best values of M and C, as we did in our linear regression course. So there is a very beautiful function over there named as log likelihood or cross entropy. Let's understand how the cross entropy works. So here I have taken the value gz and 1 minus gz, where 1 minus gz is the probability of getting 0 and gz is the probability of getting 1. So if you are giving very less number of hours, you are going to get a high probability of getting 0. And if you are going to give a very high number of hours like 12, you are going to get a high probability of getting 1 or clearing the exam and low probability of not clearing the exam. This is the formula for the cost function that I took from the research paper. But for now, we are going to ignore 1 upon n and don't worry with the complexity because we are going to dismantle this formula into part by part and understand each component. And here is the formula of loss for this problem. So in the loss you can see we have y multiplied by log or log base e gz plus 1 minus y log 1 minus gz. So all terms in this equation are pretty much relevant to the table you can see on the top. You can see that we have y, which are the actual outcomes, and we have gz, which is the probability we predicted for ones. Now, when your y is 0, if you see the last term, your first part of the equation where you are multiplying y with the probability is going to become 0 because you are multiplying 0 with the probability. But the next term where you are having 1 minus y, that will be 1 minus 0, that is equal to 1 multiplied by the log of 1 minus gz. That is the probability of getting 0 over here. Now you might be thinking how this loss will be minimized when we are giving the correct prediction. I'll get into that when we will calculate the value of these logs, and then we'll be applying this minus sign which is on the outside of this function. Now in the loss function we have actually the log base e or the ln, so we calculated the ln of both gz and 1 minus gz. And here we are multiplying the ln of gz with the y and the 1 minus y. So in the first two tables, we have taken the value of y and 1 minus y. And now I am going to multiply each y value with log of gz and 1 minus y value with log of 1 minus gz. And here you will understand how this log is actually penalizing the incorrect prediction. So let's understand in this way. Let's take the first line where you have only studied 1 hour and you were not been able to clear the exam. So actual is 0 over here, and your probability of clearing the exam is gz, which is very low. It means you are throwing up correct prediction. So in the GZ column, check out the first row. You have a very low value 4.18, 4.14 multiplied by 10 to the power of minus 8. This is the probability value you are getting, which is very low, and you are giving the low probability value of clearing the exam. It means your prediction is correct, and your 1 minus GZ, which will be very equivalent to 1, where 1 minus GZ is the probability of not clearing the exam. Okay, don't if you are getting confused, just pause a minute and see the table very carefully, because this is quite important to understand how the loss function is working. If you take the log e based or ln of very small value, you are going to get a large negative number. That's what you are getting on log base e gz. As you have predicted very low value, that's why the ln value is minus 17, which is a pretty high value. And if you see the ln of 1 minus gz for the first row, that is actually a very small value. You can recall that the log gz is going to multiply to the actual output. So your actual output or y is 0 for the first row. So a big number which is minus 17 is going to multiply with 0. So that first part of the loss function will become 0. Now we have the second term, which is actually very small, that is going to multiply to 1 minus y, which is 1 over here. And that 1, when gets multiplied to this very small value, you will end up with a very minimal loss. So in total, your loss will be very low when you are giving the correct prediction. Now just see the opposite of the first row, which is the 12th row, where you have given 12 hours to study and your GZ is very small, and your 1 minus log of GZ is very high, which is minus 16. Since you are going to clear the exam, your 1 minus y will be 0 over here. The effect of minus 16 will not be taken care in the loss because it is already going to get multiplied to 0, and the other value, which is already very small, 1.13 into 10 to the power minus 7, that is going to get multiplied to 1. In that way, your loss will be, the total loss will be very low. Now let's see what is going to happen when we will give the wrong prediction. So I'm going to change the value of m and c and see what happens over here. So I'm going to take minus 3 instead of m. You're actually saying that every time whenever you will give the exam, you're going to fail in the exam. Here, if you see the 12th row, ln of gz is minus 56, which is actually a very high value. And since you have given the wrong prediction, this minus 56 is going to get multiplied to 1, which is y, and 1 minus gz is already 0, which is already going to get multiplied to 0, not going to make any effect. So in the total loss, you are going to get 56, which is actually a pretty high value. And if you see all the values where you have given wrong prediction, starting from 7, 8, 9, 10, 11 and 12 hours, your loss is actually pretty high. In that way, you are going to penalize your equation if it gives a wrong prediction. And if you see the correct one starting from 1 to 6, there you have given the correct prediction. So all your losses are in a very low range, either 0 or into 10 to the power minus 16 or somewhere. So this is the way how the loss function of logistic regression works in real life. But guys, have you ever thought this is a lot of complex equations going on? How I can make it very simple for a computer to solve it out? So there is a simple way to do that. And here you can see that simple way. So guys, the loss can be vectorized into two matrices. The left hand side vector is representing the values of y and 1 minus y from the table. You can just wait or pause the video and look, every single value is matching. And the second vector where you have a1, a2, a3, a4, b1, b2, b3, b4 is representing the value of log or ln of gz and log e based 1 minus gz. So these two vectors, when gets multiplied, they will create a bigger vector of 2 cross 2. And if you will add each term of that 2 cross 2 vector, you are going to get the loss. And this is very simple for a computer. In single line of a code, you will be able to figure out the loss. So guys, this is all about logistic regression. If you like the video, don't forget to press the subscribe button because I used to come up with such videos every single week. So bye bye and take care. And again, don't forget to subscribe the channel. See you. Bye bye.